All right, here we go. We're talking about the last part of 3.2. This is graphing using intercept form. This is the last form. We've already talked about standard form. We've already talked about vertex form. Intercept form. If you had to guess, what do you think intercept form is going to give you?
Y-intercept.
Not the y-intercept. The two x-intercepts. If you think about it, a parabola is going to cross the x-axis in either two places. One place, exactly when it just hits right there, or no places, right? But if it crosses in two places, then we can write it in intercept form. Okay, it has a specific look to it. Y equals x minus 5 and x plus 1. You're going to know that it's intercept form, or you're going to have an idea that it's intercept form if there are two sets of parentheses. Okay? Intercept form. The first thing you're going to do is you're going to identify what the intercepts are. And it's real easy. You're just going to do the opposite of what's inside the parentheses. In this case, the intercepts are at 5, positive 5, and at negative 1. Okay? How do we get that? Well, you said x minus 5 and x plus 1. You set them equal to 0. And then you said x minus 5 is equal to 0 and x plus 1 is equal to 0. And then you said x equals 5 and x equals negative 1. I don't expect you to do all that each time. It's real easy. You just look at it and you say they're 5 and negative 1. Okay? So if we were to go ahead and graph 5 and negative 1, 1, 2, 3, 4, 5, and at negative 1, there are two intercepts. Right? We know that the parabola either looks like a U or looks like a bell, right? And the vertex is down here somewhere or up here somewhere. Okay? And there are the intercepts. I can further narrow that down. If this is positive, then what is the parabola going to look like? It's going to look like a U. It's going to be opening up. So our vertex is down here somewhere. It could be here, it could be here, it could be here. I got to figure out where it is. Okay? Anybody have an idea how I might do that? Anybody have an idea where the vertex might be?
In between those?
Exactly in between, right? We just got done talking about axis of symmetry, right? Axis of symmetry cuts it in half. Where would the axis of symmetry be in this case?
X equals 2.
Okay, let's look at that. 1, 2, 3. 1, 2, 3. So this imaginary line right here, right, goes right in between our intercepts. So we were able to narrow it down, and we were able to say, okay, at x equals 2, we have an axis of symmetry. So the parabola is somewhere, the vertex is somewhere on that line. Okay? It could be here, it could be here, it could be here, it could be here. We don't know. How could we further nail that down? How could I take this, x equals 2, and figure out where the y is going to be? Plug it back into the equation. Very good. So, y equals x minus 5 and x plus 1. If I figured out that my vertex is at positive 2, I can take 2 and stick it right there, and I can take 2 and stick it right there. So I get 2 minus 5 and 2 plus 1. That's negative 3 times positive 3, or negative 9. So where's my vertex? Now that I figured out this, where's my vertex? At positive 2, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. So there's my vertex at positive 2, negative 9. Let's see if I can make my parabola. There and there. And it should look nice and scooped right here. Nice and scooped, no V's. All right, so let's recap. If it's in intercept form, it looks totally different than standard form, looks totally different than vertex form. Instantly, I should be able to tell my intercepts. I should be able to say, hey, 5 and negative 1. Okay, are my intercepts. I could plot those. There's negative 1, there's positive 5. Then comes the tricky part. Right? I got to figure out where the middle is. Some of you were able to see that it's at positive 2. Some of you may have to do your little, dashes and figure out where it is. Let me show you another way. What is 5 plus negative 1?
Positive 4.
Positive 4. If I take the average of the two intercepts and divide by 2, what is 4 divided by 2? 2. Isn't that what I found x to be? So write that down. You can average, AVG, you could average the intercepts, right? Add them together and divide by 2 to find that line. If you don't want to try to figure it out, that's another easy method. Add them up, divide by 2. Whatever the two numbers work out to be, you could add them up and divide by 2. So once I find the x of my vertex, if I know that x equals -2, how do I go the next step and find the y? It's just like the other two methods. What do? Plug it in. I plug in 2 for x and 2 for x. And I solve. And I get -9. So I go +2, -9. There's my vertex. And it's going up. Just like that. Questions?
You said instead of just doing that, we could go 5 minus, well, I got that down. But that 2 would tell us the x, right?
Tells us the x. It tells us this line right here. It does not tell us the y. See, it could be here, it could be here, it could be here. I'm not sure where the y is. In order to find the y, I simply got to plug it in. There and there. Okay? Good question. Anybody else? Anybody else? All right, let's have you try one. Let me turn this.